Today we're going to go over spring and Hooke's law. The first question is find the spring constant for each force. The equation that you'll need here is F equals Kx. So basically we can take any point for this first spring. Let's take this one, and that's going to be at 36 and comes down to 4. So F equals Kx, 36 equals K times 4. So then divide by 4 on both sides. K equals 9. And then for this one, same thing. We're going to come straight this way and get about 32, maybe? Yeah, 32. And then 8. So then 32 equals K times 8. Divide both sides by 8. And we get that over here, K is 4. Okay? Find the amount of force required to stretch each spring 3 meters. Okay. So one easy way to do that is look at the graph and come straight up from the graph. Right? So for this one, it's pretty clear that's going to be about that and about that. But the more official way would be to plug it into the equation. Right? And so F equals 9 times 3, and F equals 4 times 3, because it's, remember, F equals Kx, F equals Kx. Okay, so for the first one, force is 27. For the next one, the force is 12. Does that match up? Yeah. That's about where we thought, and that's about where we thought. Good. Find the amount of work done. Okay, so here's a new equation. The work equation is the change in energy. We're starting with 0 energy. So basically our work is the same as our energy equation. So for spring energy, it's 1/2 kx squared. So the amount of work done is 1/2 times 9 times 3 squared, which is 9 times 9 is 81 times 1/2 is 40.5, or 1/2 times 4 times 3 squared. So 1/2 times 4 is 2 times 9 is 18, and those are joules. And I'll put the units on those two as well. Okay? Determine the amount that the spring, the 2 squares, or the spring 2, the 2 square, yeah, okay, would need to be stretched in order for 24 joules of work. So again, we're starting with 0 energy, so the amount of work done is the same as the amount of spring energy. So if it's ES equals 1/2 kx squared, and we know the amount of work is 24 is 1/2. We know K for the second spring is 4x squared. So then we have 2, divide both sides by 2. 12 equals x squared. Square root both sides. And we get x is the square root of 12, which is some number between 3 and 4. We'll leave it at that for now. Okay? The spring below has a spring constant of 25. If the block is pulled 30 meters to the right, 0.3 meters to the right, and held motionless, what force does the spring exert? So for the force, we're going to use F equals Kx. Right? So the force is our question mark, K is 25, and X is 0.3. So 25 times 0.3 is F equals 7.5 newtons. Okay, how much work was required to stretch the spring this far? Okay, work, again, is change in energy. If you start from the beginning, you have no energy, so the change is just the total energy. So 1/2 kx squared. So 1/2 times 25 times 0.3 squared. 0.5 times 25 times 0.3 squared gives us 1.125 joules. Okay. The spring at the right has a spring constant of 20. Okay, we're not doing this one. Okay. So you can kind of see how we use the Hooke's law equation and the spring energy equation to solve these problems out. Okay.